Question number 21. Which statement comparing magnesium and barium or their compounds is correct? Magnesium reacts with dilute hydrochloric acid more rapidly than barium does. This is wrong because group 2 going down the group reactivity increases. Second option is 1 mole of magnesium carbonate gives off a greater amount of gas when it reacts with an excess of dilute hydrochloric acid than 1 mole of barium does. Well, as this is mole, so wrong. Okay, when you do the chemical equation, when you write the chemical equation and you balance it, then you will say that the amount, the mole of carbon dioxide will remain same. Solubility of magnesium sulfate in water is greater than the solubility of barium sulfate in water. Well, this is our answer because going down the group of group 2 sulfate, their solubility increases. And the last one is magnesium carbonate undergoes thermal decomposition less readily than barium carbonate does. Well, this is also wrong. The reason is group 2 carbonates going down the group 2 carbonates, their thermal stability of group 2 carbonates increases. That means magnesium carbonate is less thermally stable than barium carbonate. Question number 22. The colors of silver halides, silver chloride, silver bromide and silver iodide differ. The solubility of these halides in aqueous ammonia also differ. Which row is correct? Color of silver bromide as bromide, so definitely cream or creamy, not yellow. And silver halide, that is most soluble in ammonia. Okay, so 22 answer is A. Question number 23. The name chlorate is used for an anion consisting of chlorine and oxygen only. In a molecule of ICl, the iodine atom has oxidation number of X and the chlorine atom has the oxidation number Y. Well, so we know that chlorine has the electronegativity value of chlorine is higher than iodine, so definitely chlorine is -1 and iodine is +1. Okay, when ICl is added to water, iodine is reduced, so +1 -1 and it becomes 0. So from this is reduced, it's gaining 1 electron. Okay, what is the correct statement? Which statement about the value of X or Y is correct? Okay, X is same as the oxidation number of chlorine in the chlorate ion formed when Cl2 is added to cold sodium hydroxide. Okay, so here you need to remember the chemical equation takes place when chlorine is added to cold sodium hydroxide. So when chlorine is reacting with cold sodium hydroxide, the products are sodium chloride and sodium chlorate 1, ClO plus H2O. Okay, so here this is +1, this is -1, this is +1. So in a way this statement is right because X is +1, X is +1, okay, and Y is -1. So X is the same as the oxidation number of chlorine in the corporate. Yeah, actually this is our answer. Let's check the other options also. X is same as the oxidation number of chlorine in the chlorate ion formed when Cl2 is added to hot. Okay, when it's reacting with hot, then the products are sodium chloride plus sodium chlorate 5 and water. I'm not balancing these chemical equations. I'm just looking for the oxidation number. So here the oxidation number of chlorine is plus 5. Okay, so definitely this is not our answer. Y is same as the oxidation number chlorine. Okay, so Y is -1 and chlorine added to cold. So chlorate ion. So here we have seen this is +1. So no, this is +1. +1. Okay, so definitely no. And Y is the same as the oxidation number of chlorine in chlorate ion. Okay, this is also not, because this is +5, it was -1. So our correct answer is A. Question number 24. Which statement is correct? An ammonium ion is basic due to a lone pair of electrons on the nitrogen atom. Ammonium ion is, this is wrong, because ammonium ion is not basic. This is kind of an acid because it can donate proton. Second one is nitrogen monoxide reacts with peroxyacetyl nitrate to produce component of photochemical smoke. This is also wrong, because NO does not react with peroxyacetyl nitrate. NO reacts with VOC, volatile organic compounds, to produce PAN. Okay, peroxyacetyl nitrate. Third one is nitrogen dioxide catalyzes the oxidation of atmospheric sulfur dioxide. Actually this is our correct answer, because if you remember, when sulfur dioxide and nitrogen dioxide reacts, it forms sulfur trioxide and NO, nitrogen monoxide. Okay, so here nitrogen dioxide is being reduced. It's acting as an oxidizing agent here. Okay, third one is nitrogen is very unreactive due to the very strong permanent dipole moment. No, this is wrong answer. Question number 25. The diagram shows the structural formula of a hydrocarbon molecule Q. Okay, how many of the carbon atoms in molecule Q are sp2 hybridized? Okay, this is interesting. We know that where there is carbon-carbon double bond, there is pi bond. Okay, or sp2, double bond means pi bond means sp2 hybridization. So in a way we can see that 1 2 3 3 4 5, these 5 carbons are actually they have carbon-carbon double bond, so they have one pi bond, so they are sp2 hybridized. Okay, so the problem is second carbon, if we not second carbon, in our, according to our numbering, if we just think about this, that this second carbon, it has two double bond. Okay, so we know that to form a pi bond we need one unhybridized p orbital. Okay, unhybridized p orbital, but as this one is connected with carbon number 3 and carbon number 1 and carbon number 3 with double bond, that means it has two pi bond. Here is one pi bond and there is another pi bond, so it's not possible to have sp2 hybridization. That means this one is not I mean this one should not be counted as sp2 hybridized carbon. So how many? 1, 2, 3, 4. So the correct answer is 4. Question number 26. Compound X is found in cell walls of some bacteria. Its structural formula is shown. Okay. How many stereoisomers are there with this structural formula? Okay, it has the carbon-carbon double bond. Okay, and two different group. Okay, so definitely it has geometric isocistrons. That means 2, minimum 2. Okay, and if you check this out, that this carbon and this carbon has chiral center. So from the formula of the optical isomer chiral center, calculation of the chiral center, and from chiral center how many optical isomer in any structure would have, that you have to follow this rule. So here in is 2 chiral center, so 2 2s are 4. Okay, so 2 geometric isomer, 4 optical isomer, so we always need to multiply the total number of geometric isomer and optical isomer to get the total number of structural formula. So 8. Our correct answer is 8, D. Okay. Question number 27. Structural isomers only should be considered when answering this question. Okay, we are only thinking about the structural isomer. How many straight chain isomers are there with molecular formula C4H8 Cl2? Straight chain, that means all 4 carbons are in one chain. Okay, now okay, so chlorine again, 1 position, 3 position. This is 1 2, 1 position, 3 position. Okay, 1 position, 4 position. In total 4. 1 1. Okay, 2 2. So already we have 1 2 3 4 5. What else could be? 1 1. This is 1 2, 1 3, 1 4, 1 1, 2 2. 3 3 is not possible, 2 3 is possible, right? Yeah, anything else? I don't think so. So in total we have 6 isomers. Okay, question number 18, sorry 28. What is true of every nucleophile? It attacks a double bond. No, definitely not. It donates a lone pair of electrons. Yes, it donates a lone pair of electron. It is a single atom. Not necessarily. It is negatively charged. Again, not necessarily. So the correct answer is B. Okay, question number 29. The diagram shows a synthetic route to produce 1-methyl cyclohexanol. What is reagent Y? What is this? Okay. So the carbon-carbon double bond, hydrogen bromide, that means we can have an idea that the product is something like that. Okay, heat and reagent Y, then it will form OH. Okay, reagent Y. So no, this is not Ethanolic carbon-carbon double bond will form hot concentrated. Total carbon-carbon double bond is going to break down. This is a no. So the correct answer is A. Well, so for organic chemistry, actually, there are a lot of reagents, a lot of chemical reactions, a lot of conditions, and this is difficult. I know that, but yeah, um, you need to memorize this. Question number 30. X and Y are the reagents required to convert 1-bromopropane into butanoic acid. What are the correct identities of reagent X and Y? Okay, from halogen alkane to nitrile, and from nitrile to acid. So from nitrile to acid, definitely not this. Okay, and from halogen to nitrile, definitely not this. So our answer is C.